Yep.
Off a flight?
If you want to, you can set that. Sure. Okay, so.
Hang on.
Okay, so I'm Peyton. This is Kevin. Ours is a little bit of sports theme to it. It's baseball, and we did what innings best determine total wins. Okay, so the way that I view baseball, and I play baseball here at Washburn University, is that winning the inning is the big message that our coaches try to send to us and a lot of baseball teams around the world is if you win every inning of every game, it's impossible to lose. Obviously, for Major League Baseball that has a 162-game season, you're not going to win every inning. It's just, they're the best players in the world, so it's going to fluctuate whether you win the innings. So, especially this year with the Royals winning, baseball's become a lot more popular around here, so I think people have taken a little bit more interest in baseball as opposed to what I've seen in the past few years. People want to talk about batting average, slugging, runs, hits, home runs, big stats that are really common. So me and Kevin decided that we were going to try and look at something a little bit more specific and see if winning innings would help determine your record at the end of the year. So the first thing that we did is we collected the 2015 Major League teams. We did their total wins. We didn't look at losses. Like I said, there's 162 games, so it's kind of easy to determine what your losses are just by looking at what your wins are. So we just did wins, and then we also did the first analysis that we did was we took the net runs that they scored throughout the year. So if you scored throughout the year 10 more runs than you gave up, your net total was plus 10. Other way, if you gave up 10 more runs than your net, then if you gave up 10 more runs than you scored on the year, your net total was minus 10. So that was the first analysis that we ran. So this is like, obviously this is the data set, and we also did every inning. So same thing like I said before, let's say we'll take the Dodgers for instance. They had 92 wins on the year. In the first inning they gave up 14 more runs than they scored, so they were minus 14. In the second inning they scored 30 more runs than they gave up, so they were plus 31. So we did that for every inning, and then for the total we just did the sum of each one. So where are the Royals? Royals right here. The Royals on this year scored 77 more runs than they gave up, which is great. That's what you want to do. You want to score more runs than you give up.
Mm-hmm. And so yeah, this is the average net runs per inning for the entire season.
So go ahead.
So as you can tell, this is just kind of initial model we ran just to see kind of what the data would look like and what it should look like. So over here is just a plot of the data of total wins for points for the entire game, and so that's just total net points per inning for the entire game. And so there's some pretty strong linear correlation between runs and winning. And then this is our residual plot. It looks pretty scattered, pretty evenly distributed. So there's no concerns there. I will say there are maybe a few outliers, but we decided to leave those in because those are, that's real data. We know that's accurate, and so we just decided to leave those in, and we still got a really good model.
Well, like he said, with outliers, especially in sports, I have a strong belief that there really isn't an outlier in sports. If there's no team that had just random games here and there, if there's an outlier, there's a really a good reason why there are outliers. Either I think, as you see, there was one close to negative 200 over here, which I think is in linear, or in the linear line. Then over here, there's positive 200. There are teams that have really bad pitching, and there's teams that have very dominant pitching. There's teams that have very bad, not bad, but weak offensive stats, and there's teams like the Blue Jays this year that just outscored everyone and were just bombing it everywhere. So I think that we should leave them in the model because it would help if a major league team were to look at this and say, hey, we really got outscored. It's not an outlier. It just shows there's something wrong with your pitching staff or your offensive statistics.
Is that pointed far to the right? Is that the Blue Jays?
Yeah, this is the Blue Jays. So this was the model that we just ran with one variable, and that variable we called net. So that was the net over the 9 innings, whether you scored 10 more than you scored against, not looking at each inning individually, just all nine innings. So as you can see from our F value, it's very high, which gives us a very low P value. So obviously there is the beta is not 0. And our P values for our intercept, which we don't really look at, but our net is less than 0.0001. So as you can see, there's obviously a regression line for the beta. So the beta is not 0. We can reject the null. So that's really if you would like to, the model for this would then be 80.833 plus 0.10307 times your net runs. So if you scored 100 more runs than you gave up, it would be 80.833 plus 0.10307 parentheses or times 100, and that will tell you what the predicted wins will be at the end of the year. So obviously it can be positive or negative. 80.833 was the mean for all the wins out of the major leagues. So if you give up 100, you're going to be below 80. If you score more than 100, you'll be above that. Or if you score 100 more than you give up, you would be above 80.833. So we thought that was a pretty good regression analysis, but we wanted to get a little bit more in-depth and look at each inning individually and see which innings were the best predictor for wins. So these are the scatter plots for all 9 innings. Just like the first scatter plot for residuals, they're all pretty scattered all over the place. No inning really shot out as something, oh, that doesn't really look right. They all just randomly, normally distributed, and they all look good. And you can go ahead on this one, Kevin.
So this was with this model, we just ran each inning was its own individual variable, and again it was net runs. So basically, total runs scored minus total runs given up. And as you can see, some of the innings are significant, some of them aren't. For instance, inning 1 is pretty significant. Inning 5 is very significant, and this would just kind of get a baseline reading of how our model would show, how our next models would show, just to kind of get an idea. Overall, though, it's still a very good model with the probability F value less than 0.01, so that's a good one. Also, R squared 82.9, that means it's doing really well to predict your kind of total winnings overall. So that's really good to see. And then I think
While he's doing that, I'm going to ask you a question. Is your dependent variable number of wins or percent of wins?
Number of wins.
No.
All right, so next we went with a forward selection method to try to find, the best model with, the least amount of variables or innings that we were to look at. And so as we go down, just kind of the general process that we've always followed. After that, we found that this number 4 with innings 1, 2, 5, and 7 were the best overall, having the pretty low R squared, pretty or pretty high R squared, pretty high adjusted R squared, and so on. And then after running that model separately by itself with just those 4 innings picked out, again, all of the parameters were significant predictors, and the model did pretty well. And so again, these are just some of the summary statistics overall. The analysis of variance, the p-value is pretty low. R squared is looks really nice, and so on and so forth. And you want to explain why the reasoning behind the 1, 2?
Yep. So, like you said, this was the final model that we came up with. We used 1, 2, 5, and 7. So an example that I used was, I think here I have it written down. If, for example, if you had positive 10 for the first inning, negative 3 for the second inning, positive 8 for the fifth, and positive 10 for the seventh, you would come up with 85.2736 wins, which if you won 3 out of the 4 innings is what I was saying, you're gonna 3 out of those 4 important predictor innings, you ended up with a much higher win than most of the teams. 85 wins for people who don't really understand baseball statistics is really well. That's a really good season. Anytime you can have a winning season in Major League Baseball, it's good. Very few teams actually get very many. The St. Louis Cardinals won 100 games this year, and that's like really, really impressive. And they won all 4 of these innings. From what I looked at their statistics, they won all 4 of these innings. So I thought that was, that was pretty strong correlation between that. So another big question people ask when we get to this point is why 1, 2, 5, and 7? From my baseball background, I can understand the first 2, 1 and 2, make a lot of sense because as a baseball game starts, managers will put their top 6 hitters at the top of the lineup. So the first 2 innings for every pitcher, you have to face the top 6 hitters, regardless. You're going to face the big boys. At no other inning, obviously, when you get through all 9 batters, it rolls over. But you never know if you have a great first few innings that you'll get to see more occurrence of those first 6 hitters, or if you struggled at the beginning, and it might take to the 3rd or 4th inning to see the top 6 hitters. So you might see that in 5 and 7 as like the next rollover of the top 6. But I don't think that those 2 are the reason behind that. I just think that offense is really explained here in the first 2 innings. Obviously, if you're also a pitcher who keeps the top of the order or their best hitters off balance and they can't score runs, you're gonna win. You're gonna win more because you're giving your team the opportunity to take an early lead. And if you get an early lead in baseball, it's very effective. Both physically, you're playing while you're ahead is a lot easier than always playing from behind and trying to play catch up. Also, like psychologically, it's a lot better to be winning most of the time. For 5th and 7th inning, a quality start for a pitcher in the Major League Baseball is considered to be 6 innings pitched while giving up 3 or less runs. So a lot of pitchers, and also to get a win in baseball as a pitcher, you must be winning after 5 innings. So a lot of pitchers want to get to that 5th inning just so they can help their statistics, help them in free agency, get more money to show that, hey, I won us a lot of games this year, I should be paid more. So the 5th and 7th inning are the 2 most common innings that relief pitchers come into play. So what I mean by that is after the 5th or 7th inning, they'll take out their starting pitcher, and starting pitchers are usually the best pitchers, and they'll throw in a relief pitcher. The Royals have great relief pitchers, so when they transfer over pitchers, it's not that big of a deal because they have a lot of faith and confidence in their bullpen. If your bullpen can shut down the other team's offense when they come in, you're going to win games. So this is pretty much saying if you have a strong bullpen or strong pitching after your starting pitching, you're going to win games. On the other hand, if you have a weak bullpen, your starting pitcher does a good job, but then you bring in your bullpen and they give up runs immediately, you're going to have negative net runs for these innings, and therefore your wins are going to go down at the end of the year. So that's the way I can explain why 1, 2, 5, and 7 are really good predictors, just from a baseball standpoint, not even from a statistical standpoint. So this is, with our best model, this is just the predicted value. I tried to get a bigger graph, but I just couldn't get one in SAS. So as you see, it's pretty good. I noticed that a lot of the bottom predicted stay on this side, and a lot of the top stay on this side, just like a normal regression usually would. But for the most part, I think that's pretty accurate, and especially in the mid-range near the centroid, obviously it's pretty close. And then these are just 20 of the first observations. They're, this is the wins that they had and their predicted values. One of the things that we saw is that if you had a low, it predicted really low, but if you had high runs, it predicted really high. So that was kind of an interesting thing that I saw. And this was, just like we said earlier, kind of why that model should be considered a really good model for predicting wins in the season. That's it.
Okay, any questions?